Hello, my name is Caitlin Bache. I'm an assistant editor at ASHRAE Journal. Thank you for joining us for today's webinar, part of the ASHRAE Journal Supplier Webinar Series. The series provides information to ASHRAE Journal readers and to others about products and technology of interest to industry professionals. ASHRAE does not review supplier webinar presentations. The following presentation has been prepared by Pyure. The subject is Enhanced IAQ and HVAC Performance with Photohydrolytic Hydroxyl Air Cleaning Technology. Today's speakers are Dr. Connie Arup and Dr. Kishor Khankari. Connie is the chair of the Pyure Company Scientific Advisory Board and received her PhD in organic chemistry from Princeton University. President of Chromothesis Strategies, Dr. Arup consults the companies involved in advanced air and surface cleaning technologies. Dr. Kishor Khankari is the president and founder of AnSight LLC, a noted expert in his field. He has a PhD in computational fluid dynamics from the University of Minnesota and is an ASHRAE Fellow and ASHRAE Distinguished Lecturer. Connie, the microphone is all yours.
Thank you for joining us. Please enter your questions during the presentation in the chat box on your dashboard. We will respond to them at the conclusion of the presentation and by email if we can't get to all the questions. The Pyure Company. We are a company that has been developing, manufacturing, and distributing innovative air and surface purification solutions worldwide for over 15 years. The technology is inspired by nature and based on the same chemistry driven by the sun's radiant energy. Efficacy and safety are based on extensive third-party chemical, microbiological, and toxicology testing to ensure efficacy and safety. Most of these full reports are available on the Pyure website. Pyure technology has been focused on building scalable solutions that integrate with existing HVAC systems to purify even millions of cubic feet of space. This is enabled by scaling the number of UV optics that generate the UV energy for larger spaces and deploying sensors that communicate data in real time to enable monitoring and control. Indoor air quality data obtained from these distributed sensors throughout the treatment space is presented on system dashboards along with outdoor data to enable visibility and control. Sensor data can automatically modulate system function to maintain specified performance and safety levels. We recently provided solutions for Churchill Downs Racetrack. Testing showed how Pyure improved indoor air quality by removing airborne contaminants and cleaning surfaces throughout the treatment space, even ATM keypads and bathroom door handles. Churchill Downs was delighted with the results. Listen to their story in this video by sliding the volume control at the bottom right of the screen.
Churchill Downs and the Kentucky Derby are a bucket list item for many people. So we have a huge fulfillment to deliver to the customer. Their expectations are a first-class experience, and that's what we endeavor to deliver to them as we go.
We want to make lifetime memories. We really want our guests to come as guests and leave as family. Our purpose is to produce the world's best horse race on the planet. We really strive to have excellence in everything we do and provide from a hospitality perspective, and having the Pyure Company as a part of our partners is a really important element to that.
Anything that we can possibly do to enhance the customer experience, we want to do. And the partnership with Pyure has allowed us to do that. We feel comfortable in the fact that Pyure is doing its job in those suites to help clean up. And that's really what it's doing. It's cleaning up the suite, things that they can't see. And It's a big part of our other sides of our business with casinos. When you have a lot of people up close and together, you want to do the best you can to purify the air.
My name is Chip Bach. I'm the general manager for Newport Racing and Gaming in Turfway Park. Our employees have to feel good about where they work, right? And it also, having a clean facility sets the expectation to our employees what our guest experience should be. So it's incredibly important for both groups to feel a sense of clean when they walk in. We sent a third-party air testing group out to create a baseline before we had the Pyure system in and before we had guests in the facility. And then we had them retest the air after we had guests in the facility. And the tests came back exactly as Pyure said they would. Our air quality had improved, and that was even with our outdoor air quality being worse the second time around. It overcame the outside air and still improved the air quality inside. When I used to come home from work, my clothes smelled of smoke. And my wife is very sensitive to the smell of smoke, and she'd make me get rid of them before I walked into the house. And so when the Pyure system was enabled here in Newport, and we started the smoking program here for our guests, I decided I was going to spend a weekend walking around the smoking area and then coming home to see if my wife could detect it, and she could not. That's a testament to the product working. As a matter of fact, she was so excited about the system that we ended up buying a whole house system for ourselves because she was sold from all that.
So, just how does Pyure Dynamic Protection work? It has been known for decades that the UV energy from the sun kills pathogens in air and on surfaces by generating powerful natural sanitizing agents called hydroxyls. Pyure technology simulates the action of the sun indoors by continuously generating hydroxyls. This is necessary since hydroxyls do not exist naturally indoors. They react too quickly, enabling VOC and microorganisms to accumulate to unsafe levels. The chemistry of how it works is rather simple. Pyure uses UV energy, high energy UV radiation, like the sun, to cleave water molecules. A hydrogen atom is removed from the water molecule to generate the hydroxyl radical. With an OH structure, hydroxyls are powerful oxidizing agents that kill microorganisms and react with VOC to decompose them. They do this by removing hydrogen atoms to regenerate their stable water structure. And in the process of reacting with these VOCs, they create the organic oxidants that are stable enough to circulate throughout the treatment space. Organic oxidants are also powerful oxidizing agents. They are more stable than hydroxyls, which enables them to circulate throughout the treatment space via radical chain reactions to sanitize air and surfaces. Eventually, the VOCs that they come in contact with are fully decomposed to CO2 and water, reaching low steady state levels of organic byproducts that are also continuously decomposed and do not accumulate. This is the same process that occurs outdoors in nature. Filtration is fundamentally different than what Pyure technology is. Filters do a very good job of removing particulates from air. Some types can even remove microorganisms and volatile organic chemicals. Cleaner air is recirculated back into the treatment space, where it combines with air that continues to be contaminated. There is no treatment of air and surfaces outside of the device. Microorganisms that are trapped on filters are not killed, and filters can therefore become emitters. Performance gradually deteriorates over time and gradually impeding more and more airflow until the filters need to be replaced. Pyure technology is fundamentally different. Systems begin sanitizing air inside the device where the hydroxyls are generated and where they react essentially immediately with VOC and rapidly form the organic oxidants that are circulated throughout the treatment space. So although sanitization begins in the device, it continues with the transport of these organic oxidants throughout the treatment space. Clean air and organic oxidants continue to circulate, sanitize, decompose VOCs throughout the space. As air is recirculated through the chamber, gradually all of the VOCs are decomposed as CO2 and water, leaving a very low steady state. Pyure conducted a series of studies using the SARS-CoV-2 virus in order to provide key information for use in the CFD model. In order to model how Pyure systems work synergistically with HVAC systems in the study that Kishor will describe to you, we needed experimental values for how fast the organic oxidants circulating in the treatment space actually killed the microorganisms in air and on surfaces. This data, shown here, was obtained from studies done with the SARS-CoV-2 virus in a room-sized test chamber. The airborne and surface kill rates were measured in the same study and revealed a 99% kill rate of airborne virus in 20 minutes and a 99% reduction of surface-bound virus in 60 minutes. The test chamber in which the data was collected was a real use-sized room, 8 by 20 by 8, with a device, the MDURX, properly sized for that space so that it would best represent real-world results. Airborne virus was nebulized uniformly in the chamber, while the surface samples were placed on a table as far away from the device and the oxidant source as possible to best represent oxidant lifetime. From this data, we obtained two key variables for the CFD model: the lifetime of the organic oxidant and the kill rates that they are able to generate in air. This graph shows the measured kill rate of the COVID virus that was aerosolized in the test chamber as a log reduction over time relative to a baseline. The triplicate runs were closely matched, and the data is able to be used directly from the tables in the model. The surface data, the kill rate data obtained from those samples on the table, removed from the device, was collected in a similar way, but is shown here as a log reduction of the ratio of viable COVID relative to controls. The values present as a straight line, which enables us to derive the radical lifetime of 12 minutes from the slope. With this data, Dr. Khankari will now describe how he used the information in the CFD model to compare the improvement in indoor air quality when incorporating a Pyure device with HVAC airflow.
Thank you, Dr. Arif. Hello, everyone. Hope you are doing well. If you are in Florida, hope you are safe and stay safe. So basically, as Connie said, that my role here, AnSight's role, was to evaluate the efficacy of this Pyure technology for indoor environment. And what I'm going to do is I'm going to start with air movement in a space here. When you have a room like this, the air comes from the four-way diffuser. As it enters the room, it meets the pathogens and the contaminants at the breathing zone of occupants. And the clean air doesn't remain clean. It gets dirty. And then the dirty air has to be removed from the space. What is important is the indoor air quality. Can you please not touch the screen, Connie, or whoever is doing that? Please remove your mouse from there. Let me control the presentation. So here, as I said, the clean air gets dirty, and then dirty air has to be removed from the space. What is important here is the breathing zone of occupants. It doesn't matter how clean air is near the ceiling or near the floor. What matters is the breathing zone of occupants, which is from 4 to 6 feet high. So what happens is airflow patterns, how air moves into the space, determines where all those pathogens are going. And at the same time, when the Pyure technology is equipped with the ventilation system, where those organic oxidants are going and whether they are reaching the breathing zone or not, or reaching the pathogens or not, it all depends on the airflow patterns in the space. So air is the primary carrier of heat, moisture, and airborne contaminants, and as well as the pure organic oxidants. That is the air, when it is injected into the space, air carries those oxidants in the space. Therefore, understanding the flow path of the air is the most important factor. Airflow patterns in the space determine the efficiency of ventilation. So with that, airspeed, distribution of heat, distribution of contaminants, thermal comfort of occupants, distribution of organic oxidants generated by Pyure tech machines, and then finally how effective your ventilation is, it all depends on how air moves. However, we cannot see the air movement. I'm sure wherever you are sitting now and looking around, you cannot tell me for sure how the air is moving into the space. And for that, there is a science called computational fluid dynamics that helps us to understand how air moves. Well, what we do as engineers, we draw the arrows on our drawings, correct? And that is what our intention of air movement is, where air should go. I know sometimes we even color those arrows. Blue arrow for the supplier, red arrow for the exhaust air, and so forth. However, that is our wish list. Definitely how air moves, it depends on the physics of air movement. And that's why I say air has its own mind. And unless you get into air's mind, you cannot predict how air moves. So for that, we have the science of computational fluid dynamics. As Dr. R said, that the input required for the CFD analysis came from very systematic data collection done by Pyure in the test chamber, and those were the key parameters. So how can we predict the air movement in the space? As I said, it is the science of computational fluid dynamics. It is based on sound laws of physics, of conservation of mass, conservation of momentum, conservation of energy. And once those equations are solved, we can simulate fluid flow, heat transfer, mass transfer, contaminants transfer, chemical reaction, and so forth. How it helps us? Where is this used? We are not the first one to use it. Aerospace industry uses it, Boeing uses it, automotive industry, Ford, GM, Toyota, they are using it. Chemical mixing industry to understand how well the chemicals are mixed in the pharmaceutical industry. Even the Intel and those who manufacture your phones and computers, they use it to reject the heat to the outside world so your phone doesn't get too hot. Turbomachinery industry uses it. Even the healthcare industry in neonatal section, the design of incubators. When you have a baby at risk, newborn at risk, you can't do just the experiments with that. And CFD helps us predicting this crucial air movement and environment in that incubator. Even sports industry uses it. I mean, in the swimming, the drag on the swimsuit and drag of the cyclist, even the dent on your golf ball determines the flight of your ball. So this has been widely used all over the world. And we use exactly what Boeing, Intel, GM, and Toyotas are using to test the validity of Pyure technology in indoor spaces. So in our case, it can predict the airflow patterns. I will show you that. Temperature distribution, moisture migration, contaminant distribution, and thermal comfort of the occupants, mean age of air, and ventilation effectiveness. And in our case, we are going to now determine the probability of infection with and without Pyure technology. So let's go back. Let's go to the CFD model. As you can see, this is a small office space. There are 2 cubicles. There are 6 people sitting in these 2 cubicles. And this person here with the red head is we assigned is an infected individual here. There is a supply. There is a 4-way supply here. And there is one written here, and this door is close to this room. And we are going to model this. Now, air is supplied through this 4-way diffuser, as well as the organic oxidants generated by Pyure technology are also supplied with the supplier from this 4-way diffuser. Now, here is the thing. These are the parameters. You can see this is 15 by 20 room, about 2,700 cubic feet. We use 3 air changes. And in both the cases, with and without Pyure technology, what happens if we keep the same 3 air changes? And then this photohydrolytic hydroxyl radicals, they generate these organic oxidants. As I said, they're distributed by the supplier through that 4-way diffuser here. This is the Wells-Riley correlation we used as a tool to estimate the probability of infection here. And these are the various parameters we used in our analysis. Q is the ventilation rate, which is the 3 air changes. Now, let's look at the airflow patterns here. What you can see here in the second cubicle, there is a strong recirculation of the air. Air comes out from the 4-way diffuser. It travels along the ceiling and then hits the other opposite wall and creates this large recirculation pattern. Now, remember, when air just spins the wheels at one place, it stays there for a longer time. And these organic oxidants, which are supplied through the supplier, they don't remain there forever. That's why we predicted the life of the organic oxidant that Pyure generates from a systematic experiment. And we use that life as to measure the concentration of organic oxidants. Now, the other key here is when you look in other direction, there is also 2 circulation loops where air kind of spins at one spot, and as it stays there, its age of air, what we call it, goes up, and as it goes up, naturally the concentration of the organic oxidants go down. So, as I said, the distribution of the organic oxidants in the space play important role here, and we could predict that in our CFD analysis. So, as I said, if you look at the age of the air here, which is from 0 to 1800 seconds, you can see that the red zone indicates that the age of air is much older than the theoretical average of 1200 seconds. Generally, people use 1 hour air change rates and multiply it by 60 to get the age of the air in minutes. Here you can see theoretically it's 1200 seconds, but it never happens in any space that you get the theoretical age of air. It's always more than that because of the recirculation. And you can see this is the spot where there is a stale air, if you will, and relatively fresh air here. How does it reflect on the concentration of organic oxidants, these organic radicals? And you can see where the age of air was longer, we have relatively low concentration. Doesn't mean it's zero. It's relatively lower concentration than the first cubicle. And as you can imagine, where the fresh air is coming first thing in that first cubicle, it has a lower age of air because the air is fresh there. Basically, age of air indicates the freshness of the air. Now, how does it reflect on the probability of infection? And this was really very, very revealing to us when we did this analysis. You can see, and this is a common sense, that if you sit very close to an infected individual, the probability of infection is very high. It is 15+%. And if you go very close to that infected individual, it will be 100%. So that dark red color at the breathing zone, remember I explained it to you, breathing zone of occupancy is the key parameter here. It doesn't matter what is happening near the ceiling or near the floor. We breathe in and out from 4 to 6 feet height from the floor. So basically we drink from the same well, if you will. And so you see here, there is that dark red spot is a zone of high infectivity, whereas the people on the other cubicle, where is that slightly yellow tinge, it's not zero. So they are almost 10 feet away from each other, from that infected individual. Still, their probability of infection is relatively high. Okay, so our rule of 6 foot distance works only for droplets and somebody's coughing or sneezing, but pathogens are airborne. Most of them are airborne, and therefore they can travel much longer than 6 foot distance. And this analysis shows that. So on an average, and that average means not means much, because this shows 11.3% average on that breathing plane, but the variability of infection is very high. The probability of infection is very high near the person, and it goes away as you go away from it. Now we turn on the Pyure technology from the ceiling, and now the pure oxidants will come, and you see this makes a big difference. It shows that in spite of non-uniform distribution of organic oxidants generated by Pyure, they still act on the pathogens in the space. And you can see the color, which was yellowish, has turned into green. That has significantly reduced the probability of infection in the second cubicle, where people were away about 9-10 feet. However, if you recall that previous picture, the dark red zone also has significantly reduced in this with Pyure technology. So if you recall that number of 11.3% average, that average number also reduced to 7%. And if we do our calculation, what it tells us, this is equivalent to 6 air changes, as if you are diluting this with 6 air changes. And remember, dilution is working with ventilation, but now Pyure technology is sending the army to kill the enemy at their spot and not drawing it in a tent or just diluting the enemy. So the pathogens are acted by this distributed organic oxidants into the space. Now, the next step, what I did is I created a cloud of infectivity, if you will. So this is the cloud. Under this cloud, the probability of infection is at least 10%. And look at this cloud, dirty cloud I call it. It is almost occupying 50% of that room space. It means this space here, 50% of this volume of the space has at least 10% probability of infection. Everyone in that room is under that cloud. And this is when there is no Pyure technology. This is just by dilution. The airflow patterns in this case are such that they're spreading the pathogens, and the clean air is not reaching effectively in diluting the pathogens here. Now, once we turn on the Pyure technology and release those organic oxidants, you can see that that blob, that dirty blob, that cloud has reduced by 73%. So if you look at the previous picture here and now here, it shows significant improvement. Not only we relieved these people, those 3 guys in that other cubicle, but we also reduced that cloud volume in the other cubicle. So basically from 50%, that reduced to 13.5%. And we here at AnSight, we developed this technology called Sprayed Index that evaluates the ventilation effectiveness. And that index really helps us for apples-to-apples comparison without bringing any other factors, and we normalize it. So now the other thing we did here is, once we are convinced that this is working very well, then we said, what if we reduce the air changes from 3 to 2 air changes and see what happens? So here is the same picture I was showing. This is just by dilution with 3 air changes, and the average was 11.3%. Now what we did, we reduced the air changes to 2, but activated the Pyure technology. Now those organic oxidants are coming into the room and acting on the pathogens. What it did, if you see this carefully, this was 11.3, and now this is 11.1, equivalent to 3.3 air changes. What it tells me that with Pyure technology, if we reduce the air change rates and introduce Pyure technology, we can save 33% of the energy and resources in supplying the air, but we can have the same performance, equivalent performance of those 3 air changes, if not better. And this is clear in the next cloud picture. So my sprayed index, as I explained it to you, was about 50%. It means 50% of the room has at least 10% probability of infection. Now we reduce the air changes to 2 and turn on the Pyure technology and introduce those organic oxidants here. You can see that 50% reduced to 37.2. At 2 air changes, not only we reduce the supply airflow rate, thereby reducing the first cost, thereby reducing the operating cost, thereby reducing the energy consumption and reducing the carbon emission and so forth. All these things included with reduction in the probability of infection. So not with 2 air changes, we get the similar performance of that 3 air changes dilution technology. In fact, it's better than 3 air changes dilution technology because you can see we reduced this sprayed index to 37%. So we were very happy to provide this service to Pyure and very glad to make this presentation. So what are the AnSights? And you will not find this word in the dictionary. This is coined by us. AnSights means insights through analysis. What did we learn from this analysis? First thing, this Pyure technology, the technology of introducing organic oxidants into the space by using the hydroxyls, it results in significant reduction in the probability of infection, as I demonstrated. It enhances the effectiveness of equivalent air changes. As I said, in the first case, when we kept 3 air changes, when we introduced the Pyure organic oxidants, it was equivalent to 6 air changes. The next step is it minimizes the need for high air changes. It means we don't need those 3 air changes or 6 air changes. If you are in laboratory or healthcare setting, you can reduce those air changes with the help of Pyure technology. Then, that way, it can help in lowering your first cost and operating costs. It also enables the better indoor air quality at lower air changes and reduces HVAC equipment and maintenance costs and makes buildings more energy efficient and sustainable. So, in summary, the data collected by Pyure was a very valuable resource for AnSight to perform this CFD model. So with that, I will hand it over to Dr. Arps.
Thank you, Kishor. You did a good job explaining a very complicated mathematical modeling process. So in summary, based on the model results, we've been able to demonstrate that we can improve air and surface quality in shared spaces. The cleaner the air, the healthier the individuals, and the greater the productivity. We've also shown that we can maintain high indoor air quality even at lower ACH levels, and that can translate to a significant reduction in energy use. So I put to you, why compromise? You can get the benefits of both technologies which work synergistically with one another. HVAC performance improved with the integration of Pyure air cleaning technology. I'd be glad to answer questions right now, and I will turn this over to our moderator to present the questions for you.
Hi there. Thanks, Dr. Arps and Dr. Khankari. We have time for a few questions. First one up, Dr. Arps, how do you know your unit really works?
That's a very good question. After 15 years of doing extensive third-party testing, we have been able to create an archive of extensive test data, which we publish on our website. And we've got several controlled and real-world studies available that are carried out by third parties, which have demonstrated quantitatively that pathogens are reduced in air and on surfaces. And I make the point here that it isn't the hydroxyls that are the active agent, because I see this questions coming forward. It's the organic oxidants they generate. Hydroxyls live for less than a minute, but the organic oxidants through chain reactions can survive for extended periods of time and sanitize both air and surfaces. As they travel through the treatment spaces, we've been able to measure reductions in VOC levels and demonstrated a significant reduction in odors. These studies are available for you in full reports on our website if you want to delve into them.
Next up again, Dr. Arps, this question has a few parts. How do we know that using Pyure indoors is safe? Are the organic oxidants safe? Are the organic oxidation byproducts that they generate safe? And do they accumulate?
The key to ensuring efficacy and safety indoors is to recognize that outdoor air is fundamentally safe, and we've evolved to tolerate it and even thrive in that environment. Pyure systems produce oxidant concentrations indoors that are consistent with those found outdoors. This chemistry is proven, and we've published our data in a peer-reviewed scientific journal available on the website as the cornerstone of how we are able to make the statement that the technology is fundamentally safe. Recognize that no one is concerned by oxidant levels that exist outdoors because they are very low, the high part per trillion level and the very, very low part per billion level. We create the same chemistry indoors that Mother Nature produces outdoors. Pyure has several controlled studies that shows that the byproducts of continued reactions of organic oxidants with VOC result in chemicals that do not accumulate or build up in indoor spaces. This is because we continuously recycle the air that we're treating through the photolysis chamber, generating, again, concentrations of organic oxidants and hydroxyls. This allows us to progressively break down VOCs to CO2 and water, thereby improving indoor air quality. By the way, this is the same chemistry that's been demonstrated in outdoor air and documented in the scientific literature for over 50 years. Pyure's units, particularly their induct units, are CARB certified, which is recognized as the strictest standard for safety and emissions. The MDURX portable unit was reviewed by the FDA and has been registered as a Class II medical device for safe use in occupied spaces.
Thank you. Dr. Arup's, since you need water vapor to generate hydroxyl radicals, does humidity affect the performance?
We have been able to determine that as little as 20% relative humidity will still enable our technology to produce effective concentrations of hydroxyls. From a chemical level, we know that we create more hydroxyls as a function of higher humidity levels. But it is important to recognize that in very dry areas, even as low as 20% humidity, these devices still function to specification levels and are effective.
Thank you. And we have time for one last question, and this one has come up a couple times, so let's go over it one more time. Do Pyure devices generate ozone, and if so, how are safe levels maintained?
Yes, this is a very important question. Pyure devices generate hydroxyls by using high-energy UV radiation that acts on water, and in the process, trace levels of ozone are also produced. Any device that is going to photolyze water will also produce these trace levels of ozone. Ozone does not accumulate and stays in safe limits as we recommend in our treatment spaces because we specify the device to fit the size of the space. We use less powerful optics for small size spaces, so we still generate the same concentration as we would in a large room where we scale up and use more optics to generate more radiation. CARB has evaluated our induct units and found them to be within safe limits, and the FDA has extensively reviewed all of our chemical data in the process of registering the MDURX device as safe. We've also done and published a number of controlled studies and have real-world experience with ozone. Since ozone is easy to measure in a treatment space, there are very accurate ozone sensors, and we have been able to prove that over the 15 years of our use in the field that we've been able to maintain low safe levels of ozone, steady-state levels, in our customer environments.
Thanks, Dr. Arup. We'll do one more question. We have a few minutes left. Why did you use surface data to estimate the lifetime of radicals?
This is an important parameter for use in the CFD models. Surface kill rates are only possible if the organic oxidants have a certain lifetime to enable them to, quote unquote, travel the distances that they know are sanitized. In the case of the test chamber we used, the surface-bound samples were 20 feet away from the source of the organic oxidants. And remember again, it's not the hydroxyls that are floating around the room, it's the organic oxidants. And these chemicals are more stable than hydroxyl radicals. We are looking at not only the lifetime of the individual radical when we consider this. Radicals, organic oxidant radicals, are longer lived as a functional group because they initiate radical chain reactions. So one organic oxidant will react with another VOC to create a new organic oxidant. It will then react with another VOC and create a chain of different organic oxidants. And this propagates not only innately, but also via airflow to distribute these oxidants throughout the treatment space. What's important is that the lifetime is of these radical chain reactions, not any individual one radical. And this is the value that Dr. Khankari used in his model that produced the results that we saw.
Thank you so much for answering all those questions so thoroughly, Dr. Arups. Thank you to everyone who attended this webinar today. We appreciate the time out of your busy schedules. We recommend everyone go to our website, and where you can see all of our scientific studies. They're all posted there for your consumption. And of course, we welcome questions to Dr. Arups or Dr. Khankari. The information is on the screen right now, and you will receive a follow-up email with a link to this webinar and our contact information. Any questions that we did not get to today, we will answer directly via email. So please hang tight and we will get you that information. Otherwise, thank you so much and have a wonderful rest of your day.